we are taking another example. Here is another example which is different than prisoner's dilemma, and this game gets repeated twice. So here is the stage game G, and this get repeated two times. And let us see what happens in this game. Let us say if it is being just played once, how many NAS equilibrium do we have? So if player 1 thinks that player 2 is going to play L, U is better. If player 1 thinks player 2 is going to play R, D is better, and again here U is better. Similarly for player 2, if player 2 thinks player 1 is going to play U, C is better, L gives 3, R gives 0, and C gives 4. So clearly 4 is better than 3 and 0. So 4 is the best response. And if player 2 thinks that player 1 is going to play D, then L gives 0, R gives 1, C gives 0. R is clearly best response. 1 is greater than 0. So we see that if this game is being played once only, then there are two NAS equilibrium possible, which is U comma C, which is this box, and D comma R. So now there is one difference. The earlier game that we had taken of prisoner's dilemma had only one NAS equilibrium. Now we have two NAS equilibrium. Okay, so now we have figured out that in the last stage, the smallest subgame, players would take action that lead to stage any. So in the second stage, either they are going to play U comma C or D comma R, because if they don't do this, it's not going to be an equilibrium. They will always have regret. They would feel coming back to U comma C or D comma R, because U is best response of C and C is best response of U from player 2. Similarly, for player 1, D is the best response of player 2's R, and R for player 2 is the best response of player 1 D. So both are NAS equilibrium. So in the last stage, either U comma C happen or D comma R can happen. Now the question is, in the earlier stage, can the player take the action which would not give any in the stage game? And that's where we will see the shadow of future, or we can say reputation, plays very important role. And we will also explore the role of pre-game talk. So now here the thing is that player 1 can play either U or D, and player 2 can play L, R or C. So L, R, C, L, R, C. And because they are moving simultaneously, player 2 is not able to distinguish between these two notes. And then same thing gets repeated. Let us change this, otherwise it's becoming cluttered. Here is L, R, C, and now again you get the idea. So now what's happening? How many subgames are there? One that is happening right at the beginning, one that is starting right at the beginning. And then here player 1 is acting, here player 1 is acting, here player 1 is acting, here, here, here. So there are total of 7 subgames. Okay, 1 in the first stage and 6 in the second stage. And it should be clear to you, if you look at the structure of the game, player 1 has 2 strategies, actions, and player 2 has 3 actions. So there are 6 possibilities after stage 1, that player 1 plays U, player 2 plays R. That's one possibility. Another possibility could be player 1 plays D, player 2 plays C. So, and then after each of 6 possibilities, second stage game would be played. So there are total of 7 sub games. But what is different from the earlier game? When earlier game was prisoner's dilemma that we had discussed, in the earlier game there was only one Nash equilibrium. So in the second stage, when this stage game gets repeated for the second time, players are going to defect and defect only. There is no other option. So from the second stage, it's clear that the payoff would be equal to 1, 1, or in other words, payoff is going to be 1 for player 1 and 1 for player 2. And in the first stage, in each possibility, that would get added. And because you are adding the same number everywhere, nothing is going to change. But what has changed here, that in this setting, there are two Nash equilibrium, U, C or D, R. So it's not necessary that in all the sub-game, U, C is being played. It's possible that in these 3 sub-games in the second stage, U, C is played, and in the remaining 3, D, R is being played. Because remember, each player is deciding independently. There is no external agent enforcing a particular strategy profile or particular outcome. It has to be self-binding. And we have already figured out that only Nash equilibrium is self-enforcing. Otherwise, if it is not Nash equilibrium, players have incentive to deviate. And therefore, any combination is now possible that in 6 stages, in all 6-1, U, C is played, or D, R is played, or a combination of U, C or D, R is could be played. And that's why we had said that there is a role of pre-game talk. So they can have a discussion that if you behave in this particular way, because if you pay attention to U, C or D, R, what happens? U, C is really good for player 2. Player 2 really gets very high payoff, 4. So player and D, R, D is slightly better for player 1 because D here it's 2 in comparison to 1 here, but player 2 loses from 4 to 1, 3. So is it possible that they somehow agree to play in the first stage U, L? Can player 1 entice player 2, says that if you end up playing C in the first stage and I will play, if you play L in the first stage, I will play U, I will get 4, you will get 3, and I am going to reward you by playing U in the second stage and you will play C in the second stage, and that's how you can make much more. So we have to check whether such discussion is credible or not. So this is what we are talking. We have to obtain the SPNE, and let us consider the following strategy for player. That player 1 play U in the second stage, play U in the second stage. If player 2 plays L in the first stage, play D otherwise. And player 2 play L in the first stage and then play C in the second stage if C plays L in the first stage, otherwise play R in the second stage. So this is the discussion going on between them. So let us say in the first stage gives rise to 6 different subgames. So let us say, how do we get 6 different subgames? One happens after U, L. Second happens after U, R. Third happens after U, C. Fourth happens after D, L. Fifth happens after D, R. And sixth happens after D, C. These are the 6 different possibilities. Pay attention what player 1 is saying. Player 1 is saying that I will play first U in the first stage. We are talking about not first stage, we are talking about the second stage. play U in the second stage. If player 2 plays L in the first stage, play D otherwise. So we are talking about this following strategy that they have reached to after talking to one another. What does it say? That if player 2 plays L in the first stage, play U in the second stage, otherwise play D. And here also C plays L in the first stage, otherwise play R in the second stage. So there are two possibilities in the second stage. Either they end up playing U comma C, or they end up playing D comma R. So in a way, player 1 is threatening. Both are stage equilibrium. These are stage equilibrium. We have obtained this is U comma C and this is D comma R. So if player 1 plays, if player 1 gets this box in the first one, then he rewards player 2 by concentrating on this box. So what's happening after U comma L? What is going to happen? We will have U comma C, and which is very much possible because this is a Nash equilibrium. Here player 2 doesn't play R, so here D comma R is going to happen. Here also D comma R is going to happen. Here D comma L, player 2 has played L, it means player 2 has done good behavior, so here player 2 will be rewarded with U comma C. And here again player 2 has not helped player 1, so in this way here it's D comma R is going to happen, here D comma R is going to happen. So this in the second stage, different things are possible. What we are saying that in 2 of the sub games they will get U comma C, and in 4 of the sub games they are getting D comma R. Let us see in the extensive way I have drawn what it means. Again pay attention. Play U in the first stage. So in first stage play U in the second stage. If player 2 has played L in the first stage, play D otherwise. Play L in the first stage and play C in the second stage. If C plays L in the first stage, otherwise play R in the second stage. So here what it means, this sub game is starting after player 2 has played L. So here they can get U comma C, which is a Nash equilibrium. So this is the box in the second period we get. This is 4 comma 3, 0 comma 0, 1 comma 4, 0 comma 0, 2 comma 1, 0 comma 0, U, D, L, R, C. So this is going to happen here. So we can say here in this box U comma C is going to happen. So here we are adding. Now we can say after U comma L what would happen? U comma L is 4 comma 3, and from the second stage they are going to get U comma C, which is 1 comma 4. So they will get, first player will get 5, second player will get 7. Another sub game is starting. Player 2 has played R, so here player 1 is going to focus on D, so player 2 is forced to play R. So here 2 comma 1 they will get from the second stage, and from the first stage is again U comma R, which is 0 comma 0. And here U comma C, it is 1 comma 4, but again here they will be getting D comma R from the second stage, which is 2 comma 1. So similarly we can get for all the boxes. So total payoff we can say when player 1 is playing in the first stage and thinking about what is going to happen in the second stage, the total payoff we can write LRC. This we have already obtained 5 comma 7, and 0 comma 0, because here also after D comma L player 1, this is D comma L. So here because player 2 is playing L, so here they are going to get U comma C as the reward. So we can add 1 comma 4 into L comma D. So this is going to be 1 comma 4 because earlier it was 0 0, and in all remaining boxes we can add 2 comma 1, because this is the Nash equilibrium, which is very much possible. So here if we add 2 comma 1, we get 2 comma 1. Here we will get 3 comma 5. Here we get 4 comma 2, and here we get 2 comma 1. So this is the way game would look like based on their pre-play talk. And if they are following, we have to say whether they have enough incentive to stick to this agreement or not. So we will see what is the best response here in the first stage. If player 1 thinks that player 2 is going to play L, best response is U. If player 1 thinks player 2 is going to play R, best response is D, and here best response is U. Similarly, we can, player 2 is thinking if player 1 plays U, the best response is L, and if player 2 thinks that player 1 is going to play D, best response is L. So in a way, you see here we get this stage equilibrium as U comma L, which is not a Nash equilibrium. So here the shadow of future matters, because there are two Nash equilibrium. So one Nash equilibrium is better than the others for some player, and that can be used to induce them to play this game in a particular manner. So what we have seen, that when there is only one Nash equilibrium and the finite repetition would not give anything better. But when there is more than one Nash equilibrium, shadow of future can matter, and they can get to a better equilibrium for themselves. By the way, I'm going to give you a practice problem where you have to use this. We can also talk about it if it is not clear to you. So two different cases for a simultaneous move game with unique Nash equilibrium. We have not discussed it, or a sequential move game with a unique subgame perfect equilibrium, we get unique SPNE. For a simultaneous move game with multiple Nash equilibrium, we have multiple SPNE. And why do we say multiple SPNE? Think about it, that this is one setting that we have said. What could be other Nash equilibrium? That player 1 always play D and player 2 always play R. What is going to happen? In all the second stage subgame, the payoff is going to be 2 comma 1, 2 comma 1. In all the, here also 2 comma 1, here also 2 comma 1, here also 2 comma 1, here also 2 comma 1. Sorry, not here. Here 2 comma 1, 2 comma 1, 2 comma 1, always 2 comma 1. So if you add 2 comma 1 in all boxes, again D comma R is a possibility. So there, that could be a Nash equilibrium. It's also possible that in second stage they play U comma C, and in the first stage they play D comma R. So everywhere you are adding 1 comma 4, so it would not change anything. So multiple Nash equilibrium is possibility. That's what I am talking about here. Another thing that I have not discussed, and I should very quickly say here, what did we do? We repeated a normal form game. How did we repeat the normal form game? We took the normal form game and we gave the equivalent representation in the extensive form game, and we repeated it once again. So we can also start with an extensive form game and we can repeat it multiple times, and that would be repeated extensive form game. But we have a simple name. We can simply say they all are repeated game. So what did we get? Again, let me repeat it. For a simultaneous move game with a unique Nash equilibrium, or a sequential move game with a unique subgame perfect Nash equilibrium, what do we get? There is only one possibility, that same stage Nash equilibrium gets repeated all the time. And for a simultaneous move game with multiple Nash equilibrium, what do we get? Multiple SPNE is possible. So what we are saying, that it's possible that shadow of future may not matter. If they are always playing D comma R in the previous game, the shadow of future would not matter. But there could be a situation in which the future would affect the present in a way that they would not play their Nash stage strategy profile. They will end up playing U comma L, I possibility that we discussed, U comma L, which is not a Nash equilibrium in the first stage. So that's where the shadow of future plays very important role. Thank you.